So this question asks for concavity of poise. As soon as I hear that, I am thinking second derivative, because that's how you find concavity in poise, is second derivative. If the second derivative is greater than 0, the function is concave up there. If the second derivative is less than 0, the function is concave down. And wherever the function equals 0 are the possibilities of where the function has poise. So what we need to do is concavity changes, poise happen, where concavity changes from either plus to minus, which is concave up to concave down, or minus to plus, which is concave down to concave up. That's where the points of inflection change. So we need to, first of all, find the second derivative. So we're going to take this thing, and I got to look on my screen here because I can't see that. I believe that's 4/3 and 1/3 are the power. So I'm going to do my first derivative, and I'm going to take 4/3 times 1 and lower my power by 1. Oops. And then I'm going to take 1/3 times 4 and lower my power by 1. So there is the first derivative right here. And I need to get the second derivative, so I'm going to do the derivative of this derivative. So I'm going to take 1/3 times 4/3 and get 4/9 and subtract the power of 1. And then I'm going to take negative 2/3 times 4/3, which is going to be negative 8/9, and subtract that power by 1. So there is my second derivative. Now what I'm going to do is I'm going to get rid of all my negative exponents by moving them down to the denominator. And then I want to get a common denominator. So what I know is if I multiply like bases, I add exponents. So 2/3 and 3/3, which is 1, give me 5/3. So I'm going to multiply by x on both top and bottom here to get a common denominator. So that means my second derivative is going to be 4x minus 8 all over 9x to the 5/3 power. So there is my second derivative. So now I want to find what I'm going to call critical numbers. They're not really called this, but we're going to do that. So critical numbers occur where the second derivative equals 0 or where the second derivative equals undefined. Now when you're doing these problems, I've been doing this every time. This is what I want to see you do, because it's going to remind you on the AP test to do both these things. So we can start practicing it. So we get 4x minus 8 equals 0, and you solve that and you get x is 2. And then we want to find where 9x to the 5/3 equals 0. So we get x equals 0 for that. So these are my critical numbers right here for the poise. And I hope we know this function is continuous, because we have a cube. An odd exponent in the denominator means negative numbers are fine as well. So what I want to do is I want to use the second derivative, and I'm going to use these numbers, and I'm going to plug in numbers on all sides of this thing to find out what the signs are. So and I'm going to plug them in to this thing. Okay, so if I plug in a negative down here, if I plug in a negative down here and you do a cube root of a negative, it is still a negative. And if you take a negative to a power of an odd power, it is still a negative. So when I stick a negative in, that's a negative on the bottom. And then I stick a negative in here, that's a negative minus a number, that's a negative on top. So this is going to be a positive right here. Then I go over to the 0. On the other side of 0, I'm going to stick a 1 in. So if I stick a 1 in here, that is a negative. And if I stick in a 1 here, that's a positive. So I get a negative and a positive, that's a negative. And then if I stick in a 3. Let's stick a 3 in here. This is a positive on top and a positive on the bottom, so that's a positive. I hope I got these numbers right up here. I hope that's a 4/3 and a 1/3. So it looks like to me we have a possible poi at 0. So let's plug in f of 0. Wait a second here. Let's look up here at the first derivative. Okay, we do have a little bit of a problem with this 0 value. I do get 0, 0 here, but if you look right here at the first derivative, we have a negative here, which puts the x to the 2/3 in the bottom. If I plug 0 in here, that makes this function undefined. This first derivative is undefined at 0, right? So that makes this a critical number for this, but the problem is I cannot do a second derivative if the first derivative has a 0 in the bottom where it's undefined for the first derivative. There is no second derivative for this at 0. So even though 0, 0 is in the original problem, I'm going to take a look at this on a graphing calculator, but I'm pretty sure because this is undefined with 0 in here that we can't use this one. So what I'm going to do here is this changes from negative to positive here. So I'm going to do f of 2, which is going to be 2 to the 4/3 plus 4 times 2 to the 1/3. So let's see, this right here is going to be, actually this is going to be the cube root of 16, which I could simplify that, but I don't have to, plus 4 times the cube root of 2. So that means I have a poi, there is a poi at 2, and then this number, which I could also take a 2 out of here because there's 3 2's in there. Well, let's go ahead, because that simplifies kind of nicely, doesn't it? So that goes to the 2 times the cube root of 2 plus 4 times the cube root of 2. So this is 6 times the cube root of 2 if you simplify that. So I have a poi there, and that is because f double prime changes sign at x equals 2. So what I'm going to do here is I'm going to pull up my calculator and show you. Hopefully we're going to be able to see this on the calculator. I might have to zoom in a little bit. Let me bring this over here. So I'm going to type in this original problem right here into my Y1 so you can look at it. Now, you will not be able to do a problem like this on your calculator, but I want to show you what it looks like. So I'm going to take x raised to the 4 divided by 3 power plus 4x raised to the 1 divided by 3 power. And I'm going to graph that. Let's look at my window. I'm going to go from -5 to 5 because that's where all the action happens, pretty close. And I don't know, let's go from -10 to 10, just see what it looks like. So we're going to graph that, so here it comes. Okay, just making sure I got the right number in there. Okay. So what I want to do is I want to zoom in on that middle section right there at the very middle. I hope you can see that we're concave down left over there, but 0 right there, I think we got a problem. So I want to zoom in. So I'm going to make my window really small and go from -1 to 1. I'm going to make this from -2 to 2 because I want to see what that looks like right there at the origin. So I'm going to hit trace. So look, I wonder why that's not showing up there. So I'm going to look something up real quick, but that is not showing up very nicely for us. Oh, I did not do the intervals either. I need to do the intervals where it's concave up and down. I always just went straight to the ploy. Okay, f of 0 is undefined. That's why there's nothing there. So what we want to do is we want to and it is because f double prime is not differentiable at 0. So what I forgot to do was I need to do the concavity. So let me move this out of the way and do the concavity because I didn't do that. All right, so again, the concavity is where the signs are positive, means concave up. So I should have put, since these are both positives, I should have put from f is concave up from negative infinity to 0 and 2 to infinity because f double prime is greater than 0 on those intervals. And then I should have said f is concave down from 0 to 2 because f double prime is less than 0 on that interval. I usually write, if it's only one interval, I usually write that interval because it's less writing. Okay, let me see. It looks like we got a couple of people writing questions here. Let's see. It says, do we have to show undefined for the second derivative? I thought that poise don't happen when f double prime equal. That is correct. Oh, yeah, that's correct. Poise do not happen where the second derivative does not exist. That's right, where it is undefined. So because f double prime of 0 is not a value, because you have 0 in your denominator, you cannot use that as a poi because it's undefined. So yes, you would want to say something about that f double prime of 0 does not exist. There is no point of inflection there. Okay? And that's because f double prime does not exist. Anybody else got questions on something? Do we have any other problems you guys want to talk about?
Yeah, can you do a problem from the 5/8 notes again? I've watched the notes, I just didn't understand it.
From the notes on 5/8?
Yeah, it's the very last problem.
All right, let me get the notes out from the last part. So it's going to take me a second to find those too. Well, maybe it'll come up if I do it from where I did before. Didn't come up last time, but let's see if it'll work. 5/8, you said. Come on, machine.
Yeah, so I had paused the video like you said, and I did it beforehand, and then when I saw your graph, mine was completely different, and I just didn't know
Well,
why.
I hope I tried to explain my graph to you. Let's see, we gotta go to 5.8, the last video. This is kind of weird. Where's it going? Okay, I'm getting close. So is that like F, sketch possible functions, right?
Yes. Yeah.
Okay. Trying to get this thing to be bigger. Okay, I think this is the right picture. I hope. So is this thing down here at the bottom right, is that the correct one?
Yeah.
All right, so we're going to take a look and we're going to try to figure out how to graph the original function given this information right here. All right, so this thing right here says that f prime at 2 does not exist. So in other words, you cannot do a derivative at 2. Okay, there is no derivative at 2. So that means what that tells me is there's either a vertical asymptote there or there's a sharp turn. One of those two things has to happen for f at 2. Either f at 2 doesn't exist or there's a sharp turn. Well, right here it says f of 2 does exist. So because it says f of 2 is 0, I put a point right here at f of 2. So are you okay where that comes from?
I get it. Okay, that makes sense. I thought that was f prime of 2 equals 0. I thought it was a contradiction. That makes sense.
Okay, well, I'm going to go ahead for the rest of everybody else anyway. So this says f prime is greater than 0 for all values greater than 2. So what that means is f is increasing. F is increasing from 2 to infinity. That's what that means. So we're going up on this side. And this says f prime of x equals negative a half for values less than this. So that means my slope is negative a half less than 2. So I need a slope of negative a half. Well, a negative half slope goes down 1 over 2, or you can go up 1 over 2 this way. So this is a line going this way, because that slope is constant, negative a half anywhere here. So that line is supposed to be totally straight, okay? And let's see, it says that f is concave down. So this means concave down right here. It's concave down for all values greater than 2. So that means it's going like this for all values to the right. But it also says f is increasing for all values to the right. So what that tells me is this is going to be a sharp turn because it's increasing in concave down, so it's got to be going something like that, because it's got to keep increasing forever going this way and be concave down. So that's, the picture should look something like that. Now, it doesn't have to be exactly like this. The left side should be exactly like that, but I mean, I could have made this go up higher, or I could have made it go lower, but I just need concave down and increasing the whole time. Does anybody else have anything you want me to go over? Oh, I still got the video going. It's going to be a long one. Okay, I'm getting nothing from you, so I guess we're going to call it a day. You got a quiz to take today. Again, the quiz access code is 5.6-5.7. No, there are no spaces. Yeah, guys, would please start getting your stuff turned into me. I would greatly appreciate it. I hope you have a great day, and I will see you all tomorrow at the same time. So have a good day. Stay safe. And talk to you tomorrow.